Hello learner, welcome to Manifested e-learning platform. We are going to continue with our topic on reflection and congruence. And in our today's lesson, we are going to look at symmetry lines of regular polygons. Symmetry lines of regular polygons. So at the end of this lesson, the learner should be able to identify the number of symmetry lines whenever he's given any regular polygon. So at the end of these lessons, given any polygon, whether it has 200 sides, whether it has 5 sides, whether it has 15 sides, you should be able to identify those symmetry lines. So in our case, we call them regular polygons because the number, they look regular. They have some symmetry, or the number of sides are equal. So in our case, I'll use 2 examples. I'll use a pentagon and a hexagon. So I'll start with this 5-sided regular polygon. We call it a hexagon. So if you look at it, it has those 5 sides. And we said in symmetry, we are looking for a line that will give the proportionate similarity of the 2 halves. So we have this one. And we start by looking at those lines. So let's start. I fold it along that. I've folded it along a certain line, 1. Do I get 2 halves which are proportionate? Yes. I move to the second line. I fold. Do I get 2 proportionate halves? Yes. I move to the third line. So do I get 2 proportionate halves? Yes. I move to the fourth line. So you watch carefully. Do I get 2 proportionate halves? Yes. And then I move to the fifth line. So do I get 2 proportionate halves? Yes. So I cannot continue with the 6th line because it has already been covered by line 1. What do we notice? This regular polygon called a pentagon with 5 sides has 5 symmetry lines. And where do those lines go through? They either go through the vertices or the midpoints of the sides. So a regular polygon will have 5 lines of symmetry which cutting across all the vertices and the midpoints of the sides. So a regular polygon has 5 lines of symmetry. We shall move to this second one. It is called a hexagon. It is 6-sided. It is 6-sided. So we shall start. We want to get those lines that will divide the hexagon into 2 proportionate halves. That is line number 1. Move to line number 2. That's line number 2. I've got 2 proportionate halves. I move to line number 3. I get 2 proportionate halves. I move to line number 4. I get 2 proportionate halves. I move to line number 5. 5 will still give me 2 proportional halves, and I move to line number 6. I get 2 proportionate halves. I cannot continue because number 1 has already covered the next line. So a pentagon, a hexagon, which is a 6-sided polygon, has 6 lines of symmetry. And what do we notice? We notice that any regular polygon will have the number of lines of symmetry equal to the number of sides. Because for a pentagon with 5 sides, we had 5. And where do the lines go through? They either go through the vertices or the center, the midpoint of the sides. So there is a characteristic we notice. So we notice that all regular polygons have the number of lines of symmetry equal to the number of sides and cutting through the vertices and the midpoints of the sides. So having done that, which I shall draw for a pentagon, hexagon, so as we've seen, that is a hexagon. And we noticed it had 6 lines, has 6 lines of symmetry. I clearly demonstrated that, and we have the pentagon. So those are the characteristics you'd find in the lines of symmetry of regular polygons. So whether a polygon has 100 sides, the lines of symmetry will be 100, and they'll cut across the vertices of the polygon and the midpoints of that, the sides of that polygon. So remember always that whether it is 6-sided, 7-sided, any polygon, the number of lines of symmetry is equal to the number of sides. So for that short number of characteristics, you'll fill in for the assignment. So for the assignment, you'll fill in that. So there is something else which you should know about the angles of a polygon. There is this angle. There is that angle, which will be, I think, important at times when you are deducing the lines of symmetry. The angle I've marked the sum of angles. These angles are marked. The sum of angles are marked. Sum of marked angles. So, sum of marked angles is equal to 2n minus 4 times 90. So if I want to get the sum of these, all of them, the 6 here, where n is the number of sides of polygon, is the number of sides of the polygon. I can give an example of e.g. a hexagon. E.g. for a hexagon, n will be equal to 6. So the sum of those angles, sum will be 2n minus 4 times 90. So you put 6 here, it will be 2 times 6 minus 4 times 90. 2 times 6, 12. 12 minus 4 times 90. 12 times 12 minus 4 is 8. 8 times 90, what do we get? 720. So each angle, if you want to get each angle, you'll just count the angles. There are how many? 6, and they are equal. It will be 720 over 6. So each angle will give you what? 120 degrees. They might ask you something about deducing about the angles. And having got 120, it is easier to get the other ones because they are isosceles. So at the end of the lesson, I hope you've gotten in the number of sides. Regular polygons have the number of lines of symmetry equal to the number of sides, cutting through the vertices and the midpoints of the sides. That's what you get there. And another tip on getting the sum of angles at the edge, at the vertice, that is what you'll get. So at that moment, I end the lesson, and I hope you'll fill the table before we meet in the next lesson. So thank you and bye.